Hi guys, and we're going to go over the densities of 5 liquids lab. It's another lab that just helps us talk about densities and gain a better understanding, but it's a really fun lab to do. So let me go through this with you. The first thing you're going to do is you're going to take a pipette, okay, and you're going to go ahead and find the mass of a pipette. And the pipette weighs 0.9 grams. You're going to put that on your sheet. Once you do that, then we're going to fill a pipette completely. Now, a little trick to filling a pipette. You're going to go ahead and you're going to take one squeeze, and it only gets maybe 2/3 of the way up, 3/4. Once you do that, bend it over so the air is up, squeeze out the air, and fill it, and now it'll fill completely. So once I do that, I'm going to reweigh, and I get 5.7 grams. So if I subtract the weight of the pipette that we initially had, 5.7 minus 0.9 grams, that leaves me with 4.8 grams as the mass of my water that was inside this tube. By the way, I put red food coloring in the water just so it stands out a little bit more, but that's all it is water with red food coloring. Once we do that, we're going to fill our pipette again, and we're going to calculate the volume of liquid. So I'm going to take a graduated cylinder. Now this graduated cylinder has markings for the milliliter. So I have to estimate one spot. So when I look at it really close, that is 4.8 milliliters. Okay, 4.8 milliliters. So I'm going to dump this back in here real fast. Alright, now usually we tell you not to assume everything's the same or anything like that, but for the sake of this lab, we're going to make the assumption that all of your pipettes weigh 0.9 grams and that they all hold 4.8 milliliters. So as we do the weights of these, the masses of these other fluids here, that will be important to helping us calculate density. So I'm going to go ahead and write that down. Water was 5.7 grams with the pipette minus 0.9 grams for the pipette. Leaves me as 4.8 grams for the water. Remember, density is mass divided by volume. So I take that 4.8 grams, I divide it by the 4.8 milliliters of volume. 4.8 divided by 4.8 gives me 1 gram per milliliter is the density of my water. And that's what we would expect to find for water. Let's go ahead and find the density of these other fluids up here. Excuse me. So the first one we have is isopropyl alcohol. So I'm going to fill the pipette all the way up. And when I put it up here, it weighs 4.7 grams. So I'm going to take the mass of my isopropyl alcohol, which is 4.7 grams. I'm going to subtract the weight of the pipette, which is 0.9 grams, and that gives me 3.8 grams for the mass of the actual isopropyl alcohol that was in the pipette. I divide it by 4.8 milliliters because we know that's what the pipette holds. So it's mass divided by volume, and that gives me a density of 0.79 grams per milliliter. Okay, so my isopropyl alcohol is 0.79 grams per milliliter. Now I'm going to do the mineral oil next. So I get one squeeze and I get most of it full. Get the air out and let it pull it up. And once it's totally full, I'm going to weigh that. And my mineral oil weighs 4.9 grams. I'm going to do the same process. I got to subtract out the mass of the pipette. So 4.9 minus 0.9 grams gives me 4 grams, 4.0 grams for the actual mineral oil itself. Divide it with 4.8 milliliters because we know that's how much the pipette holds. So 4 divided by 4.8 gives me 0.83 grams per milliliter. So I'm just going to talk you through the other two. The Windex, I would do the same thing, weigh it. When I do that, it weighs 5.6 grams. I subtract the 0.9, and that gives me 4.7 grams. Divided by 4.8 gives me 0.98 grams per milliliter. And the last one is this maple syrup. It is hard to get up in here, okay? It's very viscous, it's a thick fluid. So we'll go ahead, we'll get it full. It takes about 4 or 5 minutes. We'll get the pipette full, we put it on here, and the syrup weighs 7.0 grams. I subtract my 0.9 for the pipette, which gives me 6.1 grams. I take that 6.1 gram and I divide it by 4.8 milliliters, because that's the volume, and that gives me 1.3 grams per milliliter. Now, when we're talking about densities, the greatest density, the heaviest stuff, is going to be on the bottom. The lower the density, the lighter it is, the more it's going to tend to float, the higher it's going to be. Okay, just like if we put something in water. Water has a density of 1. So if the density of that object is greater than 1, it's going to sink to the bottom of the water. If its density is less than 1, it's going to float on top of the water. So we're doing the same thing with liquids. So I'm going to look at these and see which one is the most dense. The most dense one I have is the syrup at 1.3 grams per milliliter. The second most dense one I have is the water at 1.0 grams per milliliter. The third is the Windex at 0.98 grams per milliliter. It's less dense, so it should float on top of the water if all goes well. The fourth one is the mineral oil at 0.83 grams per milliliter. And then the last one, the least dense one, is the isopropyl alcohol at 0.79 grams per milliliter. I'm going to grab a test tube here, and I'm going to try to put these fluids in here. I'm going to put them slowly. I'm going to tip the tube sideways so they don't ruffle each other. And I'm going to see if these things can stack on top of each other and not mix too much. So let's start with the maple syrup. Oh, this stuff's hard to work with. Alright, so there's my maple syrup. Once I get my maple syrup, my next densest one is going to be the water. So I'm going to get some water in here. Again, it's just water with red food coloring. I'm going to hold this on its side. I'm going to put this down through here real easy. Okay, and hopefully you can see I got a nice white shirt on. You might be able to see in front of that. I've got the nice brown coloring of the syrup, and then sitting right on top of it, I got the nice red water. This is the tricky one. So I'm going to try Windex. If you go really, really slow, some of my students did a good job on this today. If you go really slow and do it at the side so it doesn't disturb the other one, that blue Windex, since it's less density, can sit right on top of that red. I'm going a little fast for the video, so I may not. Let's see. Oh, that's pretty good, isn't it? I got a nice blue layer there, followed by a nice red layer, and my nice brown syrup at the bottom. Let's go with the mineral oil. And for mineral oil, we're just using baby oil. That's all it is. Okay, let me put it on here. Again, I'm doing it easy, so I'm trying not to disturb my layers. And I've got nice 4 distinct layers. And my last one is the isopropyl alcohol. guys can see it well or not, but I've really got the syrup down here pretty good. Nice red water, my blue Windex, my oil is sitting right there, and there's a nice distinct line between the alcohol and the oil. Like I said, I don't know how well you can see that, but we're really stacking the densities. Okay. Now, the last thing I'm going to do is I'm going to put a couple beads on there. I shouldn't say the last thing, the next thing. So let's put a couple beads in there and let's see what happens to them. Well, that one sunk right through the alcohol, right through the oil, and right now it's setting on top of my Windex. So that means it's more dense than the alcohol, it's more dense than the oil, but it's not quite as dense as the Windex. So you can almost, knowing the density of those things, find the density of the object you're putting in it. Let's take another bead. Oh, that one knocked it down. So it went all the way down to the syrup, and it took the other one. The other one may have had some surface tension with it, so they're both sitting on top of the syrup right now. So they're both obviously more dense than the water, the Windex, and all that, but not as dense as the syrup. And the last one here, let's see what we got. That didn't go as planned, did it? Let's push that down there. There we go. And that one's not very dense at all. It's setting on top of the alcohol. So they're all different types of beads, and I've had them stop at different places all day, just depending on the material they're made out of. So that's kind of neat. The last thing we're going to do in this lab is we're going to take some paraffin film, okay? And it's this neat, stretchy kind of wax paper. And we're going to take the paraffin film and we're going to cover your test tube. Good. And then we're going to shake it. Oh, we had those pretty layers, and now we're going to mess it all up. There we go. And when I first do it, I get this pink mush. All right. It looks like, let me try this a little bit more. It looks like my syrup, oh, it's so viscous it's even hard to get to mix in there. But I've got this nice mush in there. Now the question is, if we let that settle, what's going to happen? Are they going to go back to their nice separate layers, or are they going to stay like that? Well, here's one that's settled for the better part of the day. And what's interesting is they settled back by their densities and into the layers, but some of them combined. So we still have maple syrup here, and it looks like we still have the alcohol on top. But the Windex, the water, some of those other things have actually combined together when we shook them. And we'll talk more about that later on when we talk about miscible and immiscible and what dissolves together and stuff. But it's just kind of neat to see that when we actually mixed them up, some of them actually dissolved together and became one color of a combined density, and some of them didn't. Okay, they wanted to stick to themselves, but they didn't want to join with those others. So I hope that gives you enough information to complete your lab. I hope you'd enjoy it, and I hope you learned from it. Thank you.